This is for the third problem of Project 5. Here we are asked to add some computation to the program count.rb so that we could get the information on the most frequent letter. For this, we can refer the program that we created before. That is the program max.rb that finds the maximum element and its index in a given array of integers. Let us first see this program max.rb. For this, activate code editor, file open, and then click home icon, and then double-click CS, double-click proj5, and then max.rb. This is the program that we studied before. It examines a given array and finds the largest value in the array and also the index of the box containing this value. I have modified the program to adjust variable names to our current context. So the array we will examine is the fleck used in the program count.rb, okay? which consists of 26 boxes. In this program, we give some example numbers, values like this, to these boxes of fleck in this way. The variable dist is used for the index, and the variable max_dist is used to keep the index of the box containing the largest value. Here is the part that does this actual computation. Let me recall what it does quickly. This is a for loop repeating this body, okay, starting from here to here, okay, before this end statement, okay. By changing the index, this value from 0 to 25. In each iteration, we check whether the current box, that is fleck of dist, has a larger value than the current champion, which is kept in the max, variable max. And then if this current champion, if this condition holds, that is the current fleck value beats the current champion value, then here we replace the value of max with the value of fleck of dist as a new champion value. We also change max_dist to remember the current index. Here for our information, I added this print command showing the new max and the new max dist. So after this for loop, we can expect that the variable max has the largest value in the array fleck, and then that max_dist has the index of the box having this max. So the program terminates by reporting these values on the screen. Note that we initially set -1 to the variable max, where -1 is chosen because we know it is less than any value in this array. On the other hand, the initial value of max_dist can be any. Here we simply assign -1, which means intuitively means undefined. Now let us execute this program. So for this, activate terminal and then go to the room for PROJ, Project 5. Okay, ls to check files there. Now let's execute this max.rb, Ruby. You see, this is the example array fleck examining in this program. Then these are the max and max_dist reported in the for loop every time we replace the value of max. First, when dist is 0, the value of the box fleck 0, this one, becomes champion. Okay, so it is reported here. Note that 0 must be the smallest number because the array has no negative number. but the initial value of max is -1. So even the smallest value 0 can be the champion when it first appears. So this 0, 0 means that this champion value is 0, which appears index 0. Then this value is soon replaced by 1 here. Okay. So this is 0, 1, 2, the second box. So it is reported that 1 beats the current champion, and which appears in the second box. Okay. So its value and index are reported here in this way. Okay. Then this one is replaced by this 2. Okay. And which is in the third box. So 2, 3 is reported. Then 5 in the fifth box, and then 8 in the sixth box. Okay, new champion values, and then they are reported here. Then the last line is the final output from the program. It reports that 8 is the largest in the array, and the index of the box containing this value is 6. Well, here, this box has the type value 8, but a replacement doesn't occur. This is because we designed our program so that it keeps the first index of the box that has the largest value if there are more than 1 boxes containing the same value. You can also make a program that reports the last index, for example, but let us use this version here. We somehow assume that the most frequent letter can be uniquely determined. Now, let us embed this part into the program count.rb. So, let's open count.rb. Okay. And then, well, as I said, in the program max.rb, we use the variable names consistent with this program count.rb. So what we need to do is simply copy and paste this max.rb. Okay, let us copy right after this. Copy. Okay. Copy this right after this. Paste. Okay, we copied this part here. Okay, let us save this and execute the program. Ruby count.rb. Okay, for example, let us type ZZZ ABB CCC. Okay. You see the 25th letter, the last letter of the alphabet, that is Z, appears the most and 4 times. So it is reported. This one, 25th letter, is appeared 4 times. Okay. Let's try with another example. Type X, Y, Z, B, C, D. The computer answered that the letter B, the letter with the index 1, is the most frequent letter, and it appears once. This is correct because B is in fact the letter with the smallest index that appears the most, which is once. So with these example executions, we may think that this is the correct one. Let us try a bit bigger example. But before doing this, okay, let us comment out this print statement. Okay, and then save. Okay, so recall that we have this message.txt. This is the message file. Let's see it again. Cat message count.txt. We have some English message here. Okay, let's examine the alphabet frequency of this message. To be count.rb and get the string from message file message.txt. All right, this result shows that a letter with index 4, 0, 1, 2, 3, 4, okay, appears 13 times, which is the most, okay, compared with others. This is the most. What is the letter with the distance 4 from the letter A? That is the letter E. You see, this is what Sherlock Holmes, the famous detective, claimed, which is indeed the hint of cryptanalysis. With this, I conclude this session.